Okay, everybody, this is our last video for this standard. This is video 6, still working on standard 1, where we're determining solutions that involve real and complex values, and we're solving quadratic equations and inequalities. And we are finally going to be using the methods that we had for equations, but applying it to an inequality situation. So this is going to involve the use of our number line and talking about intervals, because when we solve inequalities we have more than just a single answer or even just two answers, because we're talking about a whole variety of values that make something greater than or less than another number. So let's go ahead and give it a shot. So I've written down the steps, and I'm going to give you some time to write these down as well. But these are the steps for solving quadratic inequalities. And I encourage you right now to pause and to write them all down. And then when you're done writing them down, unpause and we'll chat about them. So go ahead. All right, so hopefully you've got these written down. The first one is to determine the method of finding the zeros. Determine the method that we've covered already to find the solutions. Now, solution to an equation, that is. So find the individual numbers that we came up with for any of the other methods, and we're going to use those values. We're going to place those solutions, and I have that in quotes for a reason, because those are just our end points of our intervals. And we're going to put those on a number line. Then we're going to test each section around those solutions, and this is going to determine where the actual solution sets exist. And this is going to be written as either a union of two intervals or an intersection written as a between interval. So we're going to use the same methods we had before. We're going to put them on a number line. We're going to test some values. I'll show you what that means. And then we're going to be able to write our conclusion as an interval of a union of two intervals or as a between interval. Let's go ahead and try some. So our first one is set up as the zero product property. So this one has actually already even been factored for us. So we're going to find the x values by setting them each equal to 0. And we come up with x equals 3, and on this one, when you subtract 5 and divide by 3, you get negative 5/3. So that was step 1. Solve it. Determine the solutions. Then we're going to place those solutions on a number line. And we have to make sure we put them in order, of course. So negative 5/3 is here, and 3 is over here. These are going to be open because I have an exclusive symbol, so those are open circles. The next step was to test the areas around, and we actually have 3 different areas to test. I have an area out here, I have an area in between, and then I have the area to the right of the graph. You're going to pick a value from each of those areas and you're going to test it. I'm going to grab a different color to show you. So for example, something that is smaller than negative 5/3, and you can choose an extreme value if you'd like. So maybe negative 10 is something I will test. I want to know that if I substitute a negative 10, that I get a true statement, or if I get a false statement. So when I substitute negative 10 in here, negative 10 minus 3 is negative 13. Multiply that times a 3 times negative 10 plus 5. Well, that's negative 25. When you multiply a negative times a negative, is it greater than 0? And the answer is yes. So these values over here are true. And it'll actually hold true for any value you choose on the left side of negative 5/3. Now let's try a value that falls between negative 5/3 and 3. And I'm going to choose 0. It's a nice number to substitute in. So when I test 0, 0 minus 3 is a negative 3, and 3 times 0 plus 5 is a positive 5. When you multiply those, is this value, negative 15, greater than 0? The answer is no. So these values are false. They do not work. Now let's choose another value over here. Maybe I'll choose a positive 5 to test. I'll choose a positive 5. So if I substitute in a positive 5, I get 5 minus 3, which is 2, times 3 times 5 plus 5, which is 20. So 2 times 20 is greater than 0. So that answer is yes, and this is true. So I have found values that are true over here from negative infinity up to negative 5/3, and starting at 3 going all the way towards infinity. So this is my solution set. Let's try another example. All right, first we have to put this in standard form. And I subtract the 7 over. And now I can decide how I want to solve this. I have a couple options. Actually, only two options really. I can factor this if it's factorable, or I could use the quadratic formula. I'm going to choose to factor it. So I'm going to multiply, or I'm going to set up my Punnett square before I multiply, I guess. Putting in my 2x squared here and my negative 7. I multiply and I get negative 14x squared. And I think, well, that's not too bad. I need to get a negative 13. So I have a negative 14x and a positive 1x. So I put my negative 14x in one of the boxes and my positive 1x in the other. And I go ahead and factor out my GCFs in all the directions. In this direction, I factor out a 2x. Up here, I factor out an x. In this vertical column, it's a negative 7. And over here, it's a 1. Which means my factors are 2x plus 1 times x minus 7, and it is still less than or equal to 0. Well, now I can use a zero product property. By setting each of these equal to 0, I get x to equal negative 1/2, and over here I get x to equal positive 7. If this were an equation, I would be done, but it's an inequality, so I have to figure out where the shading would occur on my graph. So I'm going to place these numbers on the number line. Of course, in the correct order. And I'm going to use solid circles this time because they are inclusive values. Now, grabbing another color pen so you can see where I'm going to do my testing. I want to test a value that's over here. I need to test a value in between, and I need to test a value on the right side. So to do this, you can test it in this, or you can test it in the factored form. It doesn't matter which form you test it in. I prefer the factored form because I think it's a little simpler to multiply that way, and I don't have to worry about messing up any positives and negatives likely. So I'm going to test a number that is less than negative 1. I'm going to test negative 2. Then in between I'm going to test a 0, and on the far side I'm going to test a positive 10. I like to pick numbers that are easy to multiply by. So I have 2 times negative 2 plus 1 times negative 2 minus 7, and I need to know if that is less than or equal to 0. It could be less than or equal to. It doesn't matter. It's not likely to be equal to 0 because I know exactly where it's equal to 0, so it's not going to happen. But, all right, I'm going to go ahead and test it, and that gives me a negative 4 plus 1, which is a negative 3, times a negative 9. This is going to be a positive number that is not less than 0. So this is false over here. Let's try substituting in a 0. That's 2 times 0 plus 1 times 0 minus 7. That gives me a positive 1 times a negative 7, which is less than 0. So this works right here. This is true in between. And then on the other side, I'm going to test a positive 10. That's 2 times 10 plus 1, that's 21, times 10 minus 7, that is 3. And I need this to be less than 0. Well, that's not going to be less than 0 because it's going to have a positive outcome. So this is false. So I have found that the values that work are between, and solid bracket there, negative 1/2 and positive 7. And that is my solution set. All right, here's example 3. So for this one, again, I have to choose the method. And I notice that I have an x and an x, but I don't have that constant term that normally follows this. So I could factor it, but I'm going to factor it using a different method. I'm going to factor this using a GCF. So both of these terms right here have a 4 and an x in common. So I'm going to factor out that 4x, and I'm going to notice that when I do that, I'm left with just an x plus a 5, still less than or equal to 0. And this way I can use these two values and set them equal to 0 using the zero product property again. So I have x equals 0 because the only thing I can multiply by 4 to turn into a 0 is a 0, and x equals 5. So those are the two numbers that I'm going to place on my number line. Are negative 5 and 0. I'm going to put those in the right order. Let's erase that so it looks nicer for us. Okay, still using a solid circle. Now I'm going to go ahead and test my regions. So I'm going to test something that's greater than 0. So perhaps I'll test a 2. And then in between, maybe a -1. And then on this side, maybe a -10. And we're going to substitute those. Again, you can substitute these in either spot, in this form or in the factored form. It doesn't matter which one. So if I use the factored form, which I prefer, I would have 4 times -10 times a -10 plus 5. So that's going to give me a -40 times a -5. And I want to know, is that going to be less than or equal to 0? And the answer is no way. That's going to be a positive number, which is not less than 0. In the next one, I'm going to test a -1. So 4 times -1 and a -1 plus 5. That makes a negative times a positive. That one is going to be less than 0. So this is true in between. And on the far side, when I test a 2, I have 4 times 2 and then 2 plus 5, which makes a positive times a positive, and that is not going to be less than 0. So these are false. So very quickly, from the step of factoring by GCF to find my two numbers, to put them on the number line, to then test the three regions, I come up with the conclusion that from -5 to 0 is my solution set. I've got one more actually. All right, for this one. This seems pretty simple. Those numbers are small. Let's go ahead and try factoring this one. So I set up my Punnett square and I put in my x squared and my -4. And when I multiply those together, I get -4x squared. And I think, how in the world am I going to make a -9? And in fact, I'm not going to be able to make a -9. So I'm going to have to use a different method. And that is, I'm going to have to use the quadratic formula for this one. Not necessarily the most fun, but we're going to give it a try. So factoring did not work. So my quadratic formula. So I have a equal to 1, b equal to -9, and c equal to -4. That makes x equal the opposite of b plus or minus the square root of -9 squared minus 4 times a times c, all over 2 times a. So I get 9 plus or minus the square root of 81 plus 8, all over 2. Continuing to solve, I get 9 plus or minus the square root of 89 over 2. Okay. So from this point, I have two values. I have 9 plus the square root of 89 over 2, and I have 9 minus the square root of 89 all over 2. And it's best at this point to determine which of those is larger than the other. So you can imagine that if I'm going to be doing 9 plus the square root of 89 divided by a positive number, that in this case, the first one is larger than the one in which I subtract. But that's not always going to be the case. So you're going to have to be careful. And for the sake of putting them on our number line, I do want to know an approximation. Not because I'm going to answer with an approximation, but just because I need to know what to test in between. So if I want to approximate this as 9 plus the square root of 89 divided by 2, that's going to be approximately 9.2. And I just did that by typing that in my calculator using the order of operations and making sure that the numerator stays together before I divide by 2. So this is approximately 9.2. On the other side, I'm going to have 9 minus the square root of 89 divided by 2. Once again, make sure you do the numerator first, and this comes out to -0.2. So again, I'm putting them on my number line. I just wanted to know about where I'm putting them. So this is my 9 minus the square root of 89 over 2, and this is my 9 plus the square root of 89 over 2. But it does give me an idea that I could test the number 0. So over here I need to test something that's smaller than -0.2. I could test -1. On this side I am going to test 0 because it falls between these, and over here I'm going to test a 0. So the only reason I use my approximations again is not because I'm going to answer with approximations, but because I want to know where I can test values. So I am going to go ahead and test the -1, and I have to use the original. So that means -1 quantity squared minus 9 times -1 minus 4, is that less than 0? That makes 1 plus 10, or 1 plus 9 minus 4 less than 0. That is false. Okay, so the next spot, oh, these should probably be open circles, right? I forgot about that. Now we can test a 0. 0 is super easy to test because 0 squared minus 9 times 0 minus 4 really just leaves me with -4 is less than 0, which is true. And then the last spot is testing the 10. That makes 10 squared minus, I'm going to go with 90 minus 4. 100 minus 94 is not going to be less than 0, so this is false. So I found the values to be true to fall right in between those. So I ran out of room here at the bottom. So my solution is these soft brackets from 9 minus the square root of 89 over 2 up to 9 plus the square root of 89 over 2. All right, it's a very strange looking answer, but that is our solution interval from the smallest to the largest values that work for this quadratic inequality. All right, I've got 2 left here for you to try. If you have any questions, you can post them on Schoology, or you can save them and ask them the next time we see each other. Great job.